Right now, a clock is running that almost nobody in Europe can hear. It counts down to a summer morning when the sun will vanish over the edge of the continent, when stars will surface in a daytime sky, and when a wall of darkness taller than the atmosphere will race across the sea faster than any jet. After that morning, the show leaves Europe for 26 years, and along the entire rim of the continent, there is exactly one place where the darkness will stay longest. That place happens to sit on the very last rock that Europe owns. The date is August 2nd, 2027. Just before 11 in the morning, local time, the moon will slide across the face of the sun above the southern coast of Spain, and for a few minutes, day will simply stop. People who have stood inside a total eclipse struggle to describe it without sounding unhinged. They talk about the temperature falling like a curtain, about animals going quiet in a wave, about a black circle in the sky surrounded by a crown of white fire. Then they usually say the same sentence: nothing on earth prepares you for it. What makes this particular morning historic is as much what follows it as what happens during it. Once the shadow leaves the Mediterranean, the geometry of the sun, the moon, and the earth turns its attention elsewhere. The eclipse tracks of the following decades fall across other oceans and other continents, and Europe waits. The next total solar eclipse to touch European ground arrives on September 12, 2053. A student watching from a Spanish beach in 2027 will be approaching middle age before the darkness returns. For older viewers, this is realistically the final totality of their lives that does not require an intercontinental flight. When astronomers call an event a hard deadline, this is what they mean. The mathematics behind that scarcity are humbling. Somewhere on Earth, a total eclipse happens roughly every year and a half, but each one paints only a thin ribbon of shadow across a planet that is mostly ocean. So for any single spot on the map, the average wait between totalities stretches to nearly 4 centuries. Whole civilizations have risen and fallen between visits of the shadow to the same city. By that arithmetic, southern Spain is about to become one of the most fortunate places in the recorded history of the sky. To understand why this morning is worth planning years around, you need to understand the absurd coincidence that makes it possible at all. The sun is about 400 times wider than the moon. The sun is also about 400 times farther away from us than the moon. Those two facts cancel each other almost perfectly, so the two brightest objects in our sky appear from the ground to be nearly identical in size. No other planet we know of enjoys this arrangement with such precision. When the moon crosses exactly between the Earth and the sun, it can cover the solar disk completely with almost nothing to spare, and the day collapses into a strange engineered night. The match is so fine that the difference between a spectacular eclipse and a disappointing one comes down to tiny shifts in orbital distance. And in 2027, every one of those tiny shifts breaks in our favor. There is a deeper reason to treasure mornings like this one. The moon is slowly leaving us. Tidal forces push it outward by roughly 4 centimeters every year, about the pace at which fingernails grow, and over immense stretches of time that drift adds up. In the distant future, the moon will appear too small to ever fully cover the sun, and total eclipses will simply end, forever, for every creature that comes after us. Earlier in our planet's history, the moon loomed larger and eclipses were common and unremarkable. We happen to live inside the narrow age when the match is nearly perfect, when totality is rare enough to feel sacred and exact enough to be total. In the deep history of the Earth, this is intermission lighting, and we are the audience lucky enough to be seated. 3 separate dials all turn to their maximum settings at once. First, the moon will be near perigee, the closest point of its orbit around the Earth, which makes it loom slightly larger than average and carve a deeper, wider shadow. Second, the Earth, in early August, rides near aphelion, the most distant point of its orbit around the sun, which makes the sun appear slightly smaller and easier to bury. Third, the path of the shadow crosses regions near the tropics around local midday, where the spinning surface of the Earth moves eastward at its fastest, in the same direction the shadow itself travels. The ground effectively chases the shadow, slowing its passage over any single observer, and a slower shadow means a longer night. Stack those 3 advantages together, and the numbers become extraordinary. At the point of greatest eclipse over the Egyptian desert near the ancient temple city of Luxor, totality will last 6 minutes and 23 seconds. For comparison, the eclipse that crossed North America a few years ago peaked at under 4.5 minutes, and many famous eclipses in history offered barely 2. Only one eclipse in living memory has lasted longer, the great totality of July 22, 2009, which reached 6 minutes and 39 seconds but spent its finest moments over the open Pacific, where almost nobody could stand beneath it. The 2027 eclipse delivers its enormous darkness onto land, onto beaches and mountain ranges and city squares, along one of the most accessible and heavily populated eclipse corridors ever mapped. Measured by totality on solid ground, it is the longest eclipse the world will see for the rest of this century. The journey of the shadow reads like the itinerary of an ancient trade route. It begins over the empty Atlantic, west of Africa, where the tip of the moon's shadow first touches the ocean at local sunrise. It races eastward, narrowly missing the island of Madeira, and makes landfall in two places at nearly the same moment, on the southern tip of Spain and the northern coast of Morocco, facing each other across the Strait of Gibraltar. From there, it sweeps across North Africa, over the Atlas region, across northern Algeria and Tunisia, and into the Libyan desert, a stretch of the planet where summer cloud is so rare that some long-term records show essentially uninterrupted sunshine on this date for decades. It reaches its deepest and slowest point over Egypt, passing near Luxor in the Valley of the Kings, where a civilization that worshipped the sun, god Ra, buried its kings beneath a sky that will briefly lose its god. Then the shadow crosses the Red Sea, darkens the Saudi city of Jeddah, brushes Yemen and the Horn of Africa, and finally lifts back into space over the Indian Ocean. In a matter of hours, one narrow ribbon of night will have crossed an entire hemisphere. The corridor of that night is enormous by Eclipse standards, roughly 250 kilometers wide at its broadest point, wide enough to swallow entire metropolitan regions with room to spare, and inside it, every town, every farm, and every stretch of empty desert will experience the same impossible thing in sequence, like a wave of midnight rolling around the daylight side of the world. Europe's share of that ribbon is small, which is exactly why the details matter so much. The band of totality clips only the far south of Spain. It covers most of the province of Cadiz, the Bay of Algeciras, the Rock of Gibraltar, and the southern edges of the provinces of Malaga, Granada, and Almeria, along with the Spanish cities of Ceuta and Melilla on the African shore. Everyone inside the band gets night at midday. But Eclipse geography is ruthless about one number, and that number is duration. How long totality lasts depends on where you stand inside the band. The center of the shadow is its deepest point, and the closer you are to the center line, the longer the sun stays hidden. Drift toward the edge, and your minutes dissolve into seconds. The city of Malaga sits just inside the northern limit, and it receives only 1 minute and 47 seconds of totality. The old port of Cadiz does better at 2 minutes and 53 seconds. Algeciras, deeper south, holds the darkness for 4 minutes and 26 seconds. Melilla reaches 4 minutes and 33 seconds. Ceuta, staring straight down the strait, tops the table of Spanish cities at 4 minutes and 48 seconds. Between the best and worst seats in Spain lies a gap of nearly 3 minutes, and every one of those seats is technically inside the same eclipse. Choosing your ground decides the whole game. Even the monuments join the lottery. From the hills near Granada, the palaces of the Alhambra will stand under a shortened totality near the northern edge, offering perhaps the most photographed backdrop of the entire path, while the quiet dunes and pine forests further south, far from any famous name, will hold the darkness twice as long. Which brings us to the question in the title. Where does the darkness last longest on the European continent itself? Follow the coast of Andalusia south until the land narrows to a point and you arrive at Tarifa. It is a small town of whitewashed lanes and surf shops, guarded by a castle that has watched the strait for more than 1,000 years. The wind almost never stops there, because the gap between two continents acts as a funnel between two seas, and the town has built its entire identity around that restless air. Just offshore, a causeway runs out to a rocky islet called the Punta de Tarifa, and that point is officially the southernmost piece of mainland Europe. Stand on it, and every capital, every mountain range, every kilometer of the continent lies behind your back. Ahead of you, close enough to see its hills on a clear day, rises Africa. On eclipse morning, the center line of the moon's shadow threads the strait just south of that exact rock. The geometry hands Tarifa 4 minutes and 39 seconds of totality, the longest darkness available anywhere on the European mainland. Consider the poetry of it. The best seat on the continent for Europe's last totality in a generation is the literal final meter of the continent. The land runs out precisely where the sky performs longest. There is an honest asterisk, and it makes the story better rather than worse. Ceuta and Melilla are fully Spanish and fully part of the European Union, yet they stand on African soil. If you count them as Europe, then Ceuta, with its 4 minutes and 48 seconds, takes the crown by 9 seconds. If you insist on the European landmass, Tarifa is the undisputed champion. Either way, the answer lives on the Strait of Gibraltar, within sight of the same water. And just across that water, the Moroccan city of Tangier squeezes out 4 minutes and 50 seconds, proof that the deepest shadow slides just south of the continent, teasing Europe from arm's length. The strait is the hinge of the whole event, the one crossing point on Earth where you could watch this eclipse from two continents in the same morning. Knowing where to stand, though, is only half the story. The other half is understanding what will happen to you when the shadow arrives. A total eclipse is not really something you watch. It is something that happens to you. For over an hour beforehand, the moon takes a slowly growing bite out of the sun. And honestly, without eclipse glasses, you might not even notice, because your eyes adapt to the fading light. Then, in the final quarter hour, the world starts to fail in ways your brain cannot file. The light turns thin and silvery, as if the sun has been swapped for a slightly wrong copy of itself. Shadows sharpen unnaturally. Sunlight passing through the leaves of trees projects thousands of tiny crescents onto the ground. The wind often shifts as the atmosphere cools. The temperature slides downward by several degrees, quickly enough to feel on bare skin. Across pale walls and sand, some observers catch shadow bands, faint ripples of light and dark shimmering like reflections on the floor of a swimming pool. Then the shadow itself arrives. From a west-facing shore like Tarifa, you may actually see it approach, a wall of darkness sweeping across the Atlantic towards you at well over 2,000 kilometers per hour. In the last seconds, the remaining sunlight funnels through valleys along the edge of the moon and breaks into beads of fire, and the final bead flares into the famous diamond ring, a single blinding jewel on a thin silver band. Then it is gone, and totality begins. The sky collapses into deep twilight blue. Stars surface at midday, and Venus blazes near the black disk where the sun used to be. Around that disk unfurls the corona, the outer atmosphere of the sun, a crown of pearly streamers and delicate arcs that the naked eye can safely see at no other moment in a human life. Around the whole horizon, in every direction at once, glows the orange of a sunset that has no single direction, because you are standing inside a pillar of shadow while the world beyond it still burns with daylight. Crickets begin to sing on the wrong schedule. Gulls either fall silent or panic. Look carefully at the rim of the black disk, and you may catch prominences, arcs of glowing pink plasma many times the size of the Earth, leaping from the edge of the hidden sun like frozen flames. Sharp-eyed observers will hunt for Mercury, the shy innermost planet that most people have never seen, briefly granted a night sky of its own beside its star. On the crowded beaches of Andalusia, tens of thousands of voices will gasp, then cry out, then drop into a hush that feels almost religious. If you can already hear that hush, take 1 second now to subscribe, because this channel tracks the rarest appointments the sky keeps and how to stand beneath them, and the road to 2027 runs straight through the videos ahead. Veterans of many totalities agree on the cruelest part, which is time. The minutes inside the shadow pass at what feels like triple speed. 4 minutes and 39 seconds will feel like 40. That is why duration is worth obsessing over, and why the difference between a sight offering 2 minutes and a sight offering nearly 5 is the difference between a glimpse and an experience. The straight is the deep end of the European pool, and depth is everything. One rival can still ruin the morning, and that rival is weather. Here the odds lean heavily in your favor. Andalusia, in August, is among the most reliably cloud-free regions of the entire continent, which is precisely why it became the holiday coast of Europe. And inland sites along the path enjoy superb chances of a clean sky. The complication is local. The strait that makes Tarifa special also funnels Atlantic moisture between the continents, and around the narrowest water, the chance of some cloud rises to roughly 1 in 3. This is the classic eclipse chaser's dilemma, because the longest darkness sits beside the trickiest sky. Many veterans will trade a handful of seconds for the clearer air of the inland hills of Cádiz province. Others will stand on the sand at Tarifa and accept the gamble, knowing that if the morning dawns clear, they will hold the best seat in Europe. The path is wide, the road network is dense, and a driver who checks the forecast at dawn and commits early can outrun most bad luck. While the crowds are gasping, scientists will be racing, because a long totality is a laboratory that cannot be built. The corona hides one of the strangest unsolved problems in physics. The visible surface of the sun simmers at several thousand degrees, yet the corona above it, farther from the source of the heat, blazes at more than 1 million. That is like stepping away from a campfire and feeling the air grow hotter, and despite fleets of space missions, the full explanation remains open. Spacecraft can block the sun with artificial disks, but those disks also hide the innermost corona, the exact region where the mystery lives. Only the moon, a perfectly smooth blocker hundreds of thousands of kilometers away, reveals that zone cleanly and only during totality. Every extra minute of darkness is extra data, which is why research teams treat an eclipse of this length the way astronomers treat the arrival of a new telescope, and why some of them will chase the shadow in aircraft to stretch their minutes even further. Eclipses have a habit of changing science. During a totality in the 19th century, observers recorded the signature of an unknown element glowing in the sun's atmosphere and named it helium, after the Greek sun god Helios, before anyone had found it on Earth. In 1919, the astronomer Arthur Eddington photographed stars beside the eclipsed sun and showed that their light had been bent by solar gravity, exactly as a young Albert Einstein had predicted. And a single dark morning turned general relativity into front-page news across the world. Even war has bowed to this phenomenon. The ancient historian Herodotus describes a battle in Anatolia between the Lydians and the Medes that stopped mid-fight when day abruptly turned to night, an event astronomers have matched to a real totality in the 6th century before the Common Era. Legend says the philosopher Thales had predicted it, and whether or not the legend is exact, it marks the moment our species began converting terror into knowledge. The 2027 eclipse belongs to a distinguished bloodline. Astronomers group eclipses into families called Saros cycles, in which near-identical events repeat every 18 years and 11 days as the geometry of the three bodies realigns. This family, known as Saros 136, is the royal house of modern eclipses. It produced the Great Eclipse of July 11, 1991, which darkened Hawaii and Mexico City, and the record-setting eclipse of 2009 across India and China. The coming eclipse is the next heir in that line, and orbital mechanics alone earns it the title of the eclipse of the century for the Eastern Hemisphere. All of this sharpens the meaning of the calendar. Europe is currently living through a brief feast in the middle of a long famine. Only weeks from now, on August 12, 2026, a short totality will brush Iceland and northern Spain with the sun hanging low in the evening sky. A beautiful but fleeting preview. Then comes the main event of 2027. After that, the continent goes dark in the wrong sense of the word, with no totality touching European ground until September 12, 2053, when the shadow returns to almost the same stage, the far south of Spain and the Strait. Anyone who misses the coming eclipse and still wants totality sooner will be booking flights toward Australia, the Pacific, or the Americas, where the shadows of the 30s will fall, and discovering what eclipse chasers have always known, that the shadow does not come to you twice in a lifetime unless you are extraordinarily lucky. Andalusia is extraordinarily lucky. The region around Gibraltar will have hosted 3 totalities within 27 years, while London, Paris, Berlin, and Rome host none at all. The sky follows geometry and nothing else, and geometry has chosen Andalusia. So treat the 2nd of August, 2027, as an appointment. Millions of Europeans live within a single day's travel of the path. Accommodation along the southern coasts has been filling years ahead, and the morning falls in the peak of the Spanish holiday season, so the roads will jam long before the moon takes its first bite. Choose a site deep in the southern half of the band. Arrive hours early, and keep the flexibility to move if the dawn forecast turns against you. Order certified eclipse glasses from a reputable supplier well in advance, because demand will empty shelves across the continent in the final weeks, and counterfeit filters that leak invisible infrared light appear before every major eclipse. If glasses fail you on the day, a pinhole punched in cardboard will project a safe image of the crescent sun onto the ground, a trick that has served observers for thousands of years. The sun will stand about 40 degrees above the horizon toward the east-southeast, high enough to clear rooftops and ridgelines, so almost any open ground with a view in that direction will serve. Bring water and shade for the Andalusian sun, and make yourself one promise. During totality, spend those minutes with your own eyes on the sky rather than on a screen, because photographs of the corona already exist by the million, while the memory of standing beneath it cannot be downloaded. Above all, protect your sight. Through every partial phase, before and after totality, the exposed surface of the sun can permanently burn the retina, which has no pain receptors to warn you while it happens, so certified eclipse glasses stay on. Only when the disk is completely covered and the corona hangs in a darkened sky is it safe to look directly, and the instant the first bead of returning sunlight flashes, the glasses go back on. 4.5 minutes of freedom, bracketed by discipline. That is the bargain the sky offers, and it is worth honoring in full. Picture the morning one final time. You are standing on the last rock of a continent, with all of Europe stretched out behind you toward the Arctic and Africa rising from a silver sea in front of you. At 11:15, the light thins, the wind hesitates, and the sun goes out. Stars return to a daytime sky. For 4 minutes and 39 seconds, the oldest fear and the oldest wonder of our species occupy the same piece of heaven, and then the world is handed back to you, slightly changed. Europe will not see its equal again until 2053. The clock from the beginning of this story is still running, and now you can hear it too. If this journey earned it, subscribe and share it with someone you would want beside you in the shadow, because the sky keeps its appointments. The next few years are full of them. Until then, keep looking up and start claiming your place on the edge of the map.